Correct. Okay. So just yeah, we discussed the asynchronous counter. No, this one asynchronous up counter. So that means yeah, Q naught is acting as a clock for the next flip flop. This is asynchronous active. This is negate of reset now. We are already seeing this one negate of reset. So for this I am going to write the code. Okay. So here you see, just I wrote the code. I'll share this codes also. Mm, So just synchronous. First up counter. Okay, up counter. So there is other name for asynchronous counter is ripple counter. No, asynchronous counter. So here module ripple underscore counter underscore 3 bit. So I'm declaring input clock, input reset, output 2 down to 0 Q. Okay. Why? Because 3 bits no. 2 down to. I need to declare the internal register, that is Q0, Q1 and Q2. Okay. So here what is stage 0? Always LSB of the flip flop always toggles no. So always at the rate an edge of clock or passage of reset begin if reset, that means reset equal to 1, I am resetting the Q naught equal to 0, else Q naught equal to not of Q naught. Okay, and stage 1 toggles on the negate of Q naught, that means always at the rate negate of Q naught or passage of reset begin if reset. If reset equal to 1, Q1 will be toggle to 0, Q1 will be initialized to 0, else Q1 will toggle to Q1. Okay, this is second stage. Is it fine? And this is first stage. This is second stage. You see, second stage toggles on the negative edge of Q1. Okay, so after getting the output of Q1 only, during the negate only, then this third flip flop will toggle. So always at the rate negate of Q1 or passage of reset begin if reset equal to 1, Q2 will be initialized to 0, else Q2 will be not of Q2. Okay, again combine the individual bits, that is assign q equal to what, I am using concatenation operation q2 q1 and q0 end module. Based on this diagram only I wrote the Verilog code. Okay, RTL code. Okay, so coming to the test bench for sequential circuits, so that 5 steps last class I told you. No, first you need to declare the internal variables like clock reset. So clock and reset with reg data type and queue with y data type. And next you need to instantiate your design in the test bench and generate the clock. Okay, hash y clock equal to not of clock and initial begin clock I am applying 0 and reset equal to 1. Okay, I am applying first I need to apply the reset. After 15 time minutes I am desetting the reset and I need to check for 0 to 7 cycles, means I need to run for 100 nanoseconds and dollar finish. Dollar monitor means if there any change in the variable, then it will display. We can see in the TCL console. So this is test bench. Is it fine? So this is up counter. And coming to the down counter, what is the difference? Down counter Q naught dash is acting as a clock for the next flip flop. No, Q naught dash is acting as a clock for the next flip flop. Okay. So I wrote the down counter also. So this is the asynchronous down counter. So if you see the asynchronous down counter, module asynchronous down counter, clock and reset I am declaring with input. Okay, input clock and reset, output 2 down to 0 Q. Okay, yeah. But here this is wire only. Why? Because after behavioral modeling, I am using concatenation operation. I am using continuous assignment statement. No? So that's why it is wire only. Okay. If I use Q in the within the procedural block, then that should be reg data type. Okay. So I am using Q outside the procedural block. That's why Q is wire data type. Okay. Is it fine? Yeah. So internal registers Q0, Q1, and Q2. So for stage 0, first flip flop LSB of the flip flop always toggle. That means always at the rate neg edge of clock or passage of reset begin if reset equal to 1 I am initializing to 0 else q equal to naught of q naught. Okay, this is stage 1. Okay, coming to stage 0, this is first stage, stage 0, and coming to the stage 1 toggles on the neg edge of q naught complement, no. So it is same as passage of q naught, no. Can I write neg edge of complement of q naught is equivalent to passage of q naught. Okay, so always at the rate passage of q naught or passage of reset begin if reset I am initialized to 0 else q1 equal to what, naught of q1. This is stage 1. Which one? Uh, Actually, like, yeah, means here within the diagram, Q naught dash, when Q naught dash is output is coming, this is acting as a clock for the next flip flop. No? Q naught dash, after getting this output only, it is acting as a clock for the next flip flop. So, that means from here, neg edge of complement of Q naught, that is equivalent to what? Passage of Q naught. No? So, that's why I wrote here passage of Q naught. When passage of Q naught is coming or passage of reset. I told you the different types of reset, no, synchronous reset and asynchronous reset. So this is related. Hmm. Yeah, it does not depending on the clock, but first I am checking. First I need to reset my design now. Reset my flip flop now. So that's why I am taking passage of reset. That means when reset equal to one, it should be 0. Otherwise, when reset equal to 0, normally it should do normal operation, functional mode. Okay, and stage 2 toggles on neg edge of complement of q naught. No, so neg edge of complement of q1 is equivalent to what, passage of q1. No? So always at the rate passage of q1 or passage of reset begin if reset equal to 1, q2 equal to what, I am initializing to 0, else q2 equal to naught of q2. Okay, this is stage 2. Okay, and at last what I need to do, I need to concatenate. So I need to concatenate, that means so here concatenation operation assign q equal to what, q2, q1 and q naught, q0 and end module. Is it fine? So this is down counter, and coming to the test bench is same only. This just the only changes we need to change in the design, like clock and reset I am declaring with range data type, and the queue I am declaring with wide data type. I need to instantiate my design in the test bench. Design name, instance name, connection by name, generation of clock, clock equal to not of clock, and the clock I am making as 0, initializing the inputs. Reset I am applying. After 15 time minutes, I am making reset equal to 0. I need to observe for 160 time minutes. And dollar monitor is for seeing the outputs in the TCL console. Seeing the outputs in the TCL console, dollar monitor. This is test page. Is it fine? Up counter and down counter. So next coming to, we already designed the mod 6 counter. No? We designed the reset logic, that is NAND gate, that is given to QB QC, that is the, no. So I designed the mod 6 counter also. So if you see the mod 6 counter, just so I need to declare input clock. I need to declare master reset underscore n. Master, that is external active low reset. Okay. So output is 2 down to 0. Reg QA QB QC wire clear underscore n. So I need to develop that is assign clear underscore n is what, master underscore reset underscore n and operation with NAND of QC and QB. Okay, and first for flip flop A, so it will toggle for every clock edge, always at the rate neg edge of clock. or negate of clear underscore n, negate of clear underscore n, begin if clear equal to 0, QA should be initialized to what? 0, no? Else QA equal to not of QA. This is flip flop A, okay? And flip flop B toggles for negate of QA, okay? Always at the rate negate of QA or negate of clear underscore n. Begin if not of clear underscore n, we need to initialize the QB to 0, else QB will be not of QB, okay? This is flip flop B, okay? And flip flop C is toggle for negative edge of QB. Always at the rate negate of QB or negate of clear underscore n. Begin if not of clear underscore n, QC will be initialized to 0, else QC equal to not of QC. At last, I am using continuous assignment statement assign Q equal to by using concatenation operator QC, QB and QA. Okay. This is my code and this is my test bench. Test bench is same only 5 steps we need to follow. That is, we need to declare clock and master underscore reset underscore in with rich data type and queue with wide data type. You need to instantiate your design connection by name and you need to generate the clock and I'm applying clock equal to 0. Master underscore reset, this is 0. After 15 time minutes, I'm releasing the reset. I need to run for 150 time minutes and dollar monitor for seeing the outputs in the TCL console. Is it fine? Yeah. This is mod 6 counter. So this is mod 6 counter. And next, decade counter also we already seen, no? Decade counter. 4 flip-flops are required. Q2, Q1 and Q3 is connected with NAND gate, NAND operation. Okay, this also we already seen. So decade counter also I wrote. Okay, whatever we discussed in the digital, I'm writing the RTL codes. Okay, Verilog codes. Yeah. So here you see decade counter. So I need to declare input clock, input reset underscore n, output 3 down to 0 Q. Why 4 flip flops are there, no? 4 flip flops. So reg Q0, Q1, Q2, these are the internal outputs of the flip flops and wire clear underscore n. And how I can develop reset logic assign clear underscore n equal to reset underscore n and of not of Q3 and Q1. Q1. Stage 0 means it will always toggle. That means always there is that negate of clock, negate of clear underscore n, clear equal to 0, it will be initialized to 0, or Q naught equal to not of Q naught. Okay. And stage 1 will toggle at negate of Q naught, no? Always at the rate negate of Q naught or negate of clear underscore n. Begin. If clear equal to 0, I am initializing to 0, or else toggle the output of the flip flop. And stage 2 toggle for negate of Q1, always at the rate negate of Q1 or negate of clear underscore n. Begin. If clear equal to 0, I am clearing the Q2 or otherwise not of Q2. And stage 3 also. So always at the rate negate of Q2 or negate of clear underscore n. Clear equal to 0, Q3 equal to 0, otherwise Q3 equal to not of Q3. At last, I am using assign statement, assign, and we are using concatenation operation. I am concatenating these 4 outputs to Q, end module. Okay. And coming to this test bench, same thing. You need to declare, so you need to follow 5 steps. Reg and clock, clock and reset underscore n we need to declare with rich data type, q with wide data type, 3 down to 0, 4 bit. Okay, I need to instantiate connection by name and generate the clock. Clock I'm applying 0 and asserting the reset. After 15 time minutes, I'm deassetting the reset. I need to run for 250 time. Why? Because if I want to run for 2 full cycles, around 200 nanoseconds will be there. So I'm running for 250 nanoseconds. Dollar finish means finish the simulation. Dollar monitor means I want to see in the TCL console outputs. I'll use dollar monitor and end model. So this is about the decade counter. Okay, is it fine? Mm. So this is about the reset counter. Latches also I wrote. See here. NAND latch we discussed, no? Latches also you see. So NAND latches. First we seen the latches. First NAND latch using NOR and NAND. We seen or not? This is NOR latch using basic latch using NOR gate, basic latch using NAND gate. Okay, so basic latch using NAND gate and NOR gate. So module NAND underscore latch input S R output reg Q and output reg Q bar. Okay. So initial begin. So you need to initialize the values Q equal to 0, Q bar equal to 1. Always at the red star case S comma R. So I am using case statement. That is 0 0 means what? Unknown state. No. By using NOR gate, okay, by using this NAND gate, NAND latch, okay. 0 1 means set state, 1 0 means reset state, 1 1 means no means memory state, okay, memory state, and test bench also same. So module TB, so S and R declare with rich data type, Q and Q bar I need to declare with by data type, and instantiating by name and dollar display, dollar monitor. I am giving some different values of S and I am seeing this. 1 0 means which state? Reset state. 1 1 means memory state. 0 1 means set state. 1 1 means memory state. 0 0 means invalid state. Okay. So this is SR latch using NAND gate. NOR gate also I wrote. NOR gate means just uh, so SR latch by using NOR gate. Yeah. SR latch by using NOR gate. So, so here if you see SR Q bar and I'm initializing always at the star means it will be applicable for all the inputs implication operator case S comma R 0 1 means reset state 1 0 means set state 1 1 means invalid state 0 0 means memory state. Okay, and you can see the test bench also same. So just 5 steps are there. So S comma R Q bar and instantiating connection by name and I am giving different values 0 0 means 0 1 means reset state 0 0 means memory state 1 0 means set state 0 0 means memory state 0 1 means set state 1 0 means invalid state 1 1 means invalid state. Okay, like this I wrote for SR latch also and just you see gated latches also I wrote and master slave flip flop also I wrote. Okay, just see and analyze and flip flop conversions also I wrote and D latch using D latch and flip flop using mux also we discussed now. D latch using mux D. Okay, yeah, yeah. So tomorrow we'll see synchronous counters and shift registers. Okay, okay, yeah.